Hello, this is our first video on complex numbers, our introduction to complex numbers. We will be doing some more videos explaining how to work with them, but this is just to get to know them. Even though the name says complex numbers, they're not so complicated, they're really easy to use. You just have to get used to them. Okay, the same as you got used to using equations with two variables, or you got used to using, you can get used to using derivatives. Well, this is just another mathematical tool. Complex numbers arise when we try to calculate the square root of a number. Okay, before, when you got to something like this, it didn't have a solution, and you would say the equation cannot be solved. From now on, it can be solved, and we will call minus 1, we will call it I. We won't say it's a solution, we won't say the value of that, we'll just call it I. You'll see some examples now. When do we use complex numbers? Why do we need them? Well, complex numbers arise when you start using mathematics to a higher level, when you get Lorentz transformations, when you get solve some differential equations. They come up a lot in engineering, especially in electricity or waves. But just to get you an idea to why we need them, one of the good things about complex numbers is that they come in pairs, you'll see now, and they can carry two informations at the same time. For example, in waves, they carry the amplitude, then they carry the frequency and the period, etc., etc. So it's like working, you have one number, but you're really working with two pieces of data. But at this level, you just have to know how to use them, and then you might start to see where they come handy. Just as the same as first you started to learn how to add and subtract, and then you started to understand more or less when you could use it. Okay, so as I said, complex numbers. Some of the things that you're going to use, we are going to call the square root of minus 1 I. Sometimes it's called j, but nearly most of the times it's called I. Okay, from imaginary, and so you can suppose that I squared is going to be minus 1 squared. This cancels the root, and then it's minus 1. So the square root of a number normally is always a positive number. In this case, you have to be careful, because I squared is a negative number. Be careful, it's minus 1. Okay? Complex numbers are formed this way. They have this structure, where A is any real number, so it can be negative, positive, fraction, irrational, whatever. Then you have the I. It can be, you can write it like that, or you can write it like that. It makes no difference. Which indicates the imaginary portion of the number, and this is another real number that can be anything. Okay, so you have really got a real as part of the complex number, and the imaginary one. Okay, so that's why I said that it can carry on the same number two pieces of information, because it has two sections. Okay, so it's any number of this form, and A can be positive and negative. There's a special version of this number which we call the conjugate of the number, which is to change the sign of the B. Okay, and that's important. You'll see now, because it comes handy when you start to operate with things. Okay, so again, I is the square root of minus 1. I squared is minus 1. You've got the number which is formed with a real part and an imaginary part, and the conjugate is to change the sign of just the sign of the complex part. Okay, of the imaginary part. Okay, so let's look at what we can do with same as we do with the rest. Adding is very easy. So if you get a number which is a plus bi, and you want to add another number which is c plus di, you just you just add the real part and the imaginary part. Okay, so you get another number which is formed by the adding of the real part and the adding of the imaginary part. B plus D, I. Okay, easy. Subtracting is exactly the same. Sorry, that's a conjugate. So you will get a plus C minus B plus D. That doesn't change. So adding and subtracting is really easy. It's like working with vectors. Get one section and add it with the same part of the other section of the number. Real part, you can add this with this and this with that. Easy. So, subtracting. We've got it. Multiplying. Okay. This is easy also, but we have to remember the square root of the square root of I. So I'll show you on an example. If we have, for example, 2 plus 3i, and we want to multiply by 4 minus 5i. Okay? So imaginary number multiplied by another imaginary number. Okay? We just multiply as if we were working with any multiplication of numbers. So I would have to multiply this by this, and this by this, and this by this, and that by that. Easy. So you get, and do get used to using the brackets when you're using imaginary numbers so that you know what you're working with. If I don't use brackets there, I wouldn't be very sure if I had to multiply this or not. Okay? So 2 times 4 is 8. Minus 5 times 2 is minus 10. 3i, that's 12i. And that's minus 15 I squared. Careful with that. Okay? So again, 2 plus 4 times 2 is 8. 2 times minus 5i is minus 10i. 3i times 4 is 12i. Plus 3i times minus 5i is minus 15i squared. So, the thing that changes now is that you get an 8, and if you see I squared is minus 1, so that minus with this minus changes into a plus, so it's plus 15, and then that's the real part. This one and this one are real, and the imaginary part is the minus 10 plus, that's a plus 2i. Okay, so it's that's a 23 plus 2i. Yep. Okay. So again, multiplying is easy. You just multiply as if you were multiplying brackets. So you multiply everything with everything. But the only part where you have to be careful is that you will obtain I squared, and that you have to change it to minus 1, and be careful with the signs. It's very easy to make mistakes there. Okay? And then I'm going to remove this because you can always watch it on the video, and I want more space to be able to do the dividing. Okay? So that's a bit more difficult. I'll show you. If you want to, it's not difficult, you just have to know what to do. So if you want to get these two numbers, the ones we had before I'm using, so that you can see we can do anything. So I'm going to divide the two numbers that we had before, 2 plus 3i divided by 4 minus 5i. I wouldn't be able to do anything here, so whenever I see this, and you've probably used it before if you're using equations where you had the divisions, you have to get rid of this denominator, so you multiply it by the, and that's the trick that you have to remember. When you divide in, you multiply by the conjugate. Okay, what was the conjugate? It was changing the sign of imaginary part. So, what I'm going to do here is a trick so that I can go on, which means I'm going to multiply all the part of the division so that it doesn't change. If not, it would change. So I'm going to multiply both up and down by the conjugate of this number. So the conjugate was to change the sign only on the imaginary part. Okay? So again, we get the numbers we were dividing and we multiply by the both on the numerator and the denominator by the conjugate of the number, of the denominator. So, what do we obtain why do we do that? Look at the denominator. If we do the multiplication here, same as we did before, so that's we were doing this, yeah, so it's 4 times 4, which is 16, and that you do as a plus 20i, okay, and then, so this one is plus 16, that's plus 20i, and by it being the conjugate, when I multiply this, that's a minus 20i again, so this one goes away. So then, and then when we multiply this, we obtain minus 25i squared. Remember, I squared is not an imaginary number. So what we're doing by this trick is removing the imaginary part of the denominator. Okay? So I'll go on here so that you see the end of it. So then you get a 16 minus 25. That's a minus 1. So it's a plus 25. Okay? And that's what you get in the end, and the denominator is 41. Okay? So that's why we did this trick. It's a trick you have to remember. So always remember, when you divide in imaginary numbers, get the denominator and multiply the whole division, both on the numerator and the denominator, by the conjugate of the denominator. Okay? And now, on the top part, we just operate. That's an 8, which we did before. That's a 10i. But now remember, it's a positive because it's a conjugate, so we'll obtain something different. That's the plus 12i, and that's the plus 15i squared. Okay? So, I always like to work real numbers on one side, imaginary numbers on the other side. So, these are real, so it's 8 minus 15, because that's a minus 1, and then you get to plus 22i. Okay? So, then you would get a minus 7 plus 22i, which is the answer, but you can even write it a bit nicer if you want, like this. Okay? So, in the multiplication of the imaginary numbers, you do it as if it were brackets, remembering that I squared is minus 1. When you divide in imaginary numbers, get the denominator, do the conjugate, and multiply both the top part and the bottom part of the division by the conjugate, so that you get rid of the imaginary part in the denominator, and then the top part, you don't really care. You operate and you get the answer. Okay? Well, that's easy. That's the basics. On the next video, we'll look at graphic representation of imaginary numbers and some more things you can do with this